continue these notes. Let's see if I get any response. So class.
Yes.
Oh, thank you, Nephi. Okay, so very small class today. All right, so I'm going to do part C, which is we're doing substitution again. Integral of e to the root x over root x dx. And just like I said yesterday, this has to be kind of like a puzzle. So any of the u sub, whatever I would call the u, would most likely be the u in this one, or chain rule. So same thing. So I'm going to say that u is square root of x. So du is going to be 1/2. Oh, come on now. 1/2 x to the negative 1/2 dx. So I'm going to rewrite this. Du is equal to 1 over 2 x to the 1/2 dx. So changing colors. So right here, this is going to be this from my dx. dx. So that means I don't want the 2. So that means I'm going to multiply both sides by 2. So it's going to be now 2 du is going to replace my 1 over x to the 1/2 and dx. So as I put that in, so integration, 2 is out front, and e to the u, and I replaced all of this on the bottom, and then now that's going to be a du. So from there, I can just go ahead and integrate that. So e to the u, just like the derivative, e to the u is e to the u. So I'm going to get 2 e to the u plus c. Now, put it back, put my u back, so that's going to be 2 e to the, I don't know, x to the 1/2 or root x. I like x 1/2 better. I don't like writing the root for some reason. Plus c. So it's always going to be a puzzle. You just got to make sure it fits. And sometimes it doesn't fit until you already start the problem. Just like this one. I didn't know about that square root of x. So on the bottom, you really didn't know what I was going to do with that one. Because, yeah. Anyway. Finding indefinite integrals using substitution. All right, right here. This is actually one of those weird key things that when you're looking at it. So I'm going to do the first one on this page and the next one. So I want to look at it and I want to use a sub to try and replace as much as I can, knowing that when I take the u, my du is going to be the derivative. So I'm looking for what would be the derivative here. So if I do that, I'm looking at this piece here to u. And if I look at that piece to u, if I take the derivative, that's going to be u squared. And that's going to be the key to me trying to figure out what I want to use for this. So let's call u is 4 x to the third minus 1. My du is going to be 12 x squared dx. All right, so now from here, I can take care of my x squared and my dx, but I can't take care of the 5. Can't take care of the 5, but I will rewrite it before I actually do everything. So u is going to be on the bottom, so I'm going to get integration of 5x squared dx still over, all this is my u. Okay, that's just a sub. Now for replacement, now for the sake of replacement, I'm going to replace this right here, so that means I got to get rid of my 12. So to get rid of my 12, I'm going to divide both sides by 12. And as I do that, those go away. So that's 1/12. And there's also a 5 right there. There's a 5 right there. So what I can do with that 5 and the 12 can go in front of my integral. So that's going to give me 5 over 12 integral. So I took care of the 5. I'm taking care of the 12. That's going to be 1 over u du. And what do we get for that one? Natural log. So it's going to be absolute value ln. So it's 5 over 12 ln absolute value of u plus c. And then from there, I'm going to put my u back. So that's going to be 5 over 12 ln absolute value of 4x cubed minus 1 plus c. Hey, I think that's Christian right there. Are we good there? Happy day? Hey, it was. Why didn't you knock?
I can't see through the windows now. I was gonna look into the wrong class.
Oh, yeah. You can knock. Oh, yeah, I don't have a problem. You were just hoping someone was gonna be in over there by the door?
No, I was gonna text him.
Oh, okay.
Yeah.
Alright, so now we're gonna do B on another page. So e to the x over e to the x plus 4. And it's going to be key knowing that my u sub is going to take the derivative. So what do I want to call u? E to the x plus 4, right? Vincent? Yeah, you agree? Or no? So from there, I can now replace all of this here with du. And then it's going to turn into integration of du over u. Now, this is exactly the same as writing it as integration of 1 over u du. Because if you think of this as a multiplication, 1 times du is du, right? So it would go up here on the top, right? So that's important to understand because you're going to see it either way. But for the sake of me, I always try to write it like this to show where my du is, and then this is part of the function. All right, so this is going to give me just ln of u plus c ln absolute value of e to the x plus 4 plus c. Alright, let's keep going. Substitution to establish integration formula. So, right here, using substitution, so we're going to prove that. We're going to prove that. So, tangent. Yeah. Alright. We know tangent represents what? Sine of a cosine. So I could rewrite this as integration of sine x over cosine x dx. Alright. And we know using substitution, we do derivative. One of these derivatives is going to give me the other. So, what do we want to do? So, because derivative of sine is going to give me cosine, and derivative of cosine gives me negative sine. So, either one I choose, it's going to work. So, you want to try cosine? Yeah? Okay. Alright, so u cosine x du is negative sine x dx. Alright, so now I have my top portion right here, which is going to take care of all of this. And then my u is going to take care of this. Now I just have to deal with the negative right here. So let's go ahead and move the negative to the other side. So divide both sides by negative, so it's going to make that a negative there. So I have a negative integral of 1 over u du. Alright, and integrate this now. So I'm going to get negative ln absolute value of u plus c, which is going to give me negative ln, it's an n, absolute value of cosine x plus c. Now, there was a second one over here on this. Okay, how would I do the second one? We could, but how about just doing instead of using sine, we could use cosine for u. That would work too, right? So either way, it's going to give me the same things. Or logarithm rule, change it to 1 over cosine. Yeah. But just for the sake of the integration, you can see using substitution, I can get both of these answers. Alright, finding indefinite integral using substitution. Here's another one. We're going to have to try and figure out which one this is using, I don't know. So, like I said, chain rule. If it looks like it would be a chain rule, that's what I want to try and pick to be my u. Christian, I'll let you tell me what I should use. 4 plus x? Okay. not working out the same because they're the same degree, right? Yeah. It's the same degree, so, but I can't have any x's. I can't have any x's, okay? Just like my x, I want to get rid of it as quick as possible. See what I did there? See what I did there? Yeah, okay. Tree, did you get that one? Okay, alright. So, u is equal to 4 plus x. Can I also say that u minus 4 is equal to x? Yes, I can. Can we do it? Okay, never mind. Fine, forget you all. Alright, so I'm going to replace x with u minus 4, and I'm going to x plus 4 is going to be replaced with u. So now I'm going to have integration. I'm replacing x with u minus 4, and I'm replacing all this with u. So that's going to be u to the 1/2.
That works.
Isn't this, all this right here, the u? Is that what you were asking, or what? No?
Just keep going.
Okay. And then, my dx is equal to my du. Alright, before I can get too far into this, see this right here, isn't this a multiplication? Let's make my life easier and distribute it. U to the 1/2 times u to the first is going to be u to the 3/2 minus 4u to the 1/2 du. Now can I integrate these? Yeah? Pretty straightforward, right? Adding, so it's going to be u to the, what do we got here?
Wait, 3u.
Right now this is 3/2, right? Integration.
5.
Very good. 5/2 times what?
Times 5.
Remember,
Times
we're dividing by this, right? So it's same as multiplying by the reciprocal, so that would be 2/5, right? And over here we have minus 4, u to the 3/2 times what?
2.
Over.
3.
There we go. And so I have that, and then my plus c. So this turns into 2/5 u 5/2 minus 8/3 u 3/2 plus c. And put my u back. Two over 5. Parentheses. U is 4 plus x to the 5/2 minus 8/3 to the 3/2 plus c. Tree, did that answer your question? Will you finish the problem? good? A lot taken in, right? What would you try and do here? I think this is the one that was supposed to complete the square. That was my notes. Yeah, this one right here. Super weird because it's the 1 over Alright. Does it look a whole lot like that? This one we're gonna have to complete this one. Do you remember what that one is? It's an arc. Not tangent. Tangent doesn't have a radical. Cosine? Sine? Cosine. My notes say sine. Huh? The minus sign always gets me. I'm like, which one is it? So it looks like it should be an arc sine. But it's not really there yet, is it? So I'm gonna try to make it into this. But that 4 is gonna mess me up. So I'm gonna factor out a 4. If I factor out a 4, okay, it's gonna give me 1, right? And minus x squared over 4. And then I'm gonna rewrite that again too. Because that's gotta be a perfect square, and that 4 needs to be changed a little bit. Isn't 4 just 2 squared? So that's gonna turn into So that's what I needed to get to. I needed this to get to this. So I had to manipulate it a little bit. So in that manipulation, do I have multiplication inside the radical? If I had that inside the radical, that means that I could separate it into 2 separate radicals. I could turn it into I could turn it like that. And square root of 4 is just 2, isn't it? So now I'm down to the nitty-gritty. So now I could rewrite this. That's going to be a 2. It's a 1/2, right? front of my integral, 1/2, 1 over like that. But doesn't match perfectly. It doesn't match perfectly, is it? So that's where my u comes into place. So I'm going to call the u my complicated part. My u is x over 2. My du is going to be 1/2 dx. So by doing that one little step right there to change that into a u, I now have this as, I gotta take care of that 1/2 also. There is the 1/2 that's already out there, that's this one, times 1/2 from this integration 1 over square root of 1 minus u squared du. Oh crap, it's not, because I'm replacing this one right here. I've added another one. I'm sorry, forgive me. I'm replacing this because there was this one here. Oh no. There was this one here. There was this one here that was already there, so that's going to replace the 1/2 that's there. I didn't need to add another one. So I'm sorry if I'm making you rewrite stuff. So there we go. So that 1/2 took out the 1/2 that's right there. I don't know why I was adding another one. And then from here, I have du. This was still a dx. I forgot to copy that one down. Anyway, I could do that one right there, which is going to give me arc sine of u plus c. So that turns into arc sine of, that's a negative, my x to the x over 1, I'm sorry, x over 2 close plus c. There we go. Is that correct, Tree? I almost understood it. What about sine? No, that's arc. So it's not reciprocal. It's arc. Is that what you're saying? Yeah. All right. Okay. So other questions on that one? We're going to use the same method for part B. So same method on part B. Dx 9 plus 4x squared. There we go. Same method, but right here on the bottom, that plus sign and a square right there, that's a tangent. That one's going to be a tangent. But my arctangent should look like this. It should look like 1 over 1 plus x squared. It should like that. That would be my arctangent on that one. So I got to try and make it into that. So by doing that, I'm going to start by taking care of that 9, so by dividing both sides by 9. So that's going to turn into, let's see, I'm going to go 1, 9, parentheses 1 plus 4x squared over 9. And isn't 4 a perfect square? Isn't 9 a perfect square? So I want to write those as one term squared. So that's going to turn into 1 plus 2x over 3 squared. Yes? Okay. Alright, so now I can see what my u is going to be. My u is going to be my 2x plus 3. I'm sorry, 2x over 3. Why did I say plus 3? du is 2/3 dx. And then, let's see, it doesn't go out clearly, so what I'll do is I'll divide this or multiply both sides. So I can get dx is equal to 3 over 2 du. And rewriting this with my u, take out my 9 out front, I get 1 over 9 times, because this one's on this side here, so it's a multiplication on that one, 3 over 2, integration of 1 over 1 plus u squared du. Reduce that a little bit. It's going to be, what, 1/6 arctangent plus c? Yes, 1/6 arc. That's going to reduce. And then put it back. There we go. Did tree approve? Alright, before we actually get into this, because we're going to end up changing bounds on this one, this is like a completely different animal. So I'm going to leave this one for tomorrow and let you guys work on it. So make sure you like, share, and subscribe.